Racing the beam is fun too.
Let's do it.
Almost as fun as gleaming the cube.
Hello and welcome to the HACKADAY podcast. I'm Elliot Williams.
And I'm Kristina Panos.
This is episode 242. This week we'll be talking mechanical math, KaboomBox, and racing the beam. In the news this week, we are in the final stretch of preparation for Supercon. We just announced that Cory Doctorow is giving the keynote speech.
Whoa.
Yeah, I think that's super cool. Tom is actually just unbelievably stoked. He's a huge Cory Doctorow fan. I read Little Brother back in the day, and I follow a lot of his stuff on EFF. His current shtick is enshittification, which is kind of how the big bad internet monopolies are not just slurping up our consumer surplus, but how they're also trying to ruin the internet along with it, and what we can do about it. It's not a political talk. It's kind of like an policy advocacy, how the heck are we going to save the internet talk.
Sounds important to me.
So I think it'll be really cool. I've actually read an interview with him about this topic before, and I do find myself nodding my head a lot along the way. So it's going to be super fun to see that live at HACKADAY Supercon next week.
I read something of his a long time ago. It was probably Little Brother.
Yeah. Actually, Jonathan Bennett reviewed his Red Team Blues, which is a fiction story about people doing Red Team hacking professionally.
Oh.
And Jonathan, being kind of our computer security guy, really enjoyed it. So again, super stoked to have him giving the keynote. And that'll be, at 10 in the morning, 8 days from when you're listening to the podcast, if you're listening to it on Friday.
As you should.
I'm kidding. Yeah, that's right. But during Supercon, you're forgiven for heading over to our YouTube channel and watching some of the talks as they go by live. And what else is going on? The Halloween contest. Halloween? The Halloween contest is still going on HACKADAY, and that ends also in a week.
Less than a week.
Yikes. So get your Halloween hacks in ASAP. You've been following along with these a lot, haven't you?
Yes, I have. I've been hogging them.
That's awesome. Thank you for writing them up.
You're welcome.
What was your favorite? Find any good ones?
Oh, wow. I still really like the musical jack-o'-lanterns and the Ouija robot, as you said.
Oh, Ouija robot is super awesome.
It's pretty darn. And our own Tom Nardi's Hasbro Kids Proton Pack conversion.
Oh, I didn't see that one.
In the show notes. I swear I have seen this before, and I looked for us where we wrote it up, and I couldn't find it, and maybe there was a previous I.O. project, and I didn't go that far. Oh. But I know I have seen it before.
Now that you say that, didn't he do that last year for Halloween, and he's just now writing it up? Is this possible?
Perhaps.
Because this is sounding familiar now.
Yeah. The pack, the toy is from like 2021.
Mm-hmm.
So.
Wow, well, good for him. Oh, that looks really cool. I'm looking at it now.
Yeah.
Holy. Was it all? I wonder what parts of it. Oh, there you go. There's before and after.
Do you see? Yeah, okay.
Oh my God, it looks much better after. I was going to say, those props are basically cobbled together out of what kind of electrical crap you have in your closet anyway. So it's not going to be super hard for Tom to embellish this one. And then I look at it and boom, there's a big ribbon cable prominently featured and some awesome caution signs. He's added a bunch of electronics and lights and blinkies to it, of course, which, Halloween, right?
Oh, yeah. We'd love to see it.
He did the whole painting and prop modeling, weathering and all of that. Holy cow.
Learned it from Adam Savage, I think.
Serious.
Silver Rub and Buff is what it's called.
Is that right?
Yeah, it's not like silver underneath. It's blue underneath. I think the silver is on top. Made a frame for it, a metal frame.
So that you can carry weight in your fake empty plastic proton pack. Yeah, that is hardcore. Well, good job, Tom. HACKADAY employees and their relatives are ineligible to enter the ineligible to win in the contest. But that's awesome, and good for him for tossing that in anyway. No prize.
Have some candy.
This is a journey into sound. What's that sound?
Shall we then head on to What's That Sound?
Let's do it.
We have a special sound this week?
Oh, if you say so.
I don't know. I haven't heard it yet. I'm actually going to listen to it right now.
Oh, you haven't? Okay.
No.
I thought you listened to it back when I sent it to you.
Did I?
I don't know.
Oh, maybe I listened to it and I still don't know what it is. All right, well, I'm listening to it again. Here we go.
Okay.
It's very clicky. It's ratchety. It could be any number of mechanical, shuttery, latchy things. It feels like a camera, but it feels even more like a Viewmaster.
Ooh.
What was it?
It is a...
I absolutely never would have guessed that. That's awesome.
Somewhat low-tech, like I said.
Yeah.
Very useful, though.
Well, I was totally stumped by that. So if you out there have a guess, head on over to hackaday.com/podcast, fill out the form, and leave your handle and your best guess, and we'll see if somebody gets this next week. And whoever does and gets picked out of the hat will get a Hackaday podcast t-shirt.
So good luck to you.
All right, well, let's head on off to hacks. I wanted to start off with a new one from Ken Shirriff, reverse engineering the mechanical Bendix central air data computer. I picked this one because those old school mechanical computers just absolutely baffle and astound me. And this one is particularly well explained by Ken. If you've seen his IC teardowns, if anyone can maybe kind of explain to you how ICs are built, it would be Ken. And he does a similarly good job taking apart this entirely mechanical calculating machine. This one in particular, the air data is that it was some kind of flight computer from the 1950s that was calculating airspeed and Mach number and air density and stuff when airplanes were finally getting to go fast enough that this sort of non-normal behavior of fluids started to matter. And what's cool is he explained to me something I've never known about these, and that is, if you think about a mechanical computer, it works by turning one shaft and then you get the answer out on another somewhere. And in between is this crazy set of gears and linkages and cams and who knows what else. Things like multiplication are pretty obvious how you do it. You know, you just use gear ratios. So if you have a 3-to-7 gear ratio or whatever, it does that multiplication or division for you. And that I was kind of cool with. But how you do addition and subtraction, I didn't know. And the answer is it's a differential. It's a differential like the one on the front of your car. There's an absolutely fantastic old video about how differentials work. And if you don't know yet, I'll have to link that one for you. But what they serve to do is take the number of turns coming from your engine and distribute it across your two wheels on either side of the car so that the wheel going around the outside of the curve turns more and the wheel going around the inside of the curve turns less because you're on a different radius and stuff, right? That, it turns out, is actually doing addition and subtraction. It's taking the total number of turns and splitting it up between the two wheels. And then, of course, there's all of the nonlinear math stuff. There's cams and followers. And so, if you needed to calculate a logarithm, you would cut a logarithmic pattern into the diameter of a cam and you'd have that move around. Or you would have something following a cylinder of changing diameter so that it rolled a certain number of times. Really, really incredible stuff. Very well explained. This is a super teardown, and you should have a look at it if you want to at least get a clue about how these crazy mechanical computer things did absolutely insane math. It's taking the seventh power of things and,
Boggles the mind.
It does. Yeah, well, my mind is a tiny bit less boggled by it now.
Well, that's good.
Now, if you asked me to engineer something that mechanically calculated square roots, I would do what Ken did, and I would cut a logarithmic profile into some cam, and I would use a 2-to-1 gear ratio, and it's kind of funny. You actually could do this sort of thing that they did back in the day. If you want to see some really amazing old mechanical computers, I've got a couple cool links for you. One from 2014, which is a harmonic analyzer, which did Fourier analysis all with gears and wheels. And this was one of the early videos by the engineer guy, and it's a set of 4, I think. You should absolutely go check that out. Harmonic analyzer, mechanical Fourier computer. And you should also check out an old Air Force one from 2013, mechanical targeting computers, similar to this one that Ken tears apart, except it's old training movies to show you how to maintain these crazy mechanical targeting computers from back in the day, which is really cool because to fix one of these things, you have to understand how it works. So it's a good demo too.
I live very close to the site, a former site of a Bendix plant.
Oh yeah?
Mm-hmm. They moved it though, and it's something else now.
What kind of Bendix?
They made non-nuclear parts for nuclear applications.
That's specifically non-specific.
Yes. All right. My first hack is KaboomBox is a firecracker of a music player. This is from HACKADAY alum Cameron Coward. So the 8-track experience, not so great, right? With the ka-chunking.
Yeah.
But the players, a lot of the players were very cool. And this one is no exception. It looks like the detonation box for some TNT, and it even has a handle that lets you do that motion to change the tracks. Don't worry, it didn't work anymore, but now it's working in a new way, a new lovely fashion. So essentially it is reading RFID stickers out of 8-track tapes and playing sound files off of an off of an SD card. But I still think that's very cool, and I might have to do it myself. I think I will do it myself. I'm going to try it with cassettes, and I'm going to try to leave the tape in there, because I think the sticker will fit inside and work through the cassette tape, probably.
Oh, would you put it inside a cassette tape?
Yeah.
Ooh, that's a good idea.
I don't want to see it.
Yeah.
So the new guts are a Raspberry Pi Pico and naturally an RFID reader, plus the DF player that you would expect, and of course an SD card reader. I like that he doesn't mention this, but he used an extender, like a panel mount SD card with an extender. I don't know. I just thought that was cool.
So like
kind of had to.
Yeah, right. So it can fit through, or?
No. So he could reuse the ports on the side that were already there for like the power plug.
Ah, right. Got it. Yeah.
And you reuse the original speaker.
Yep.
For a nice sound. A nice vintage sound.
Yeah, I was going to say that 80s sound. Yeah. He actually did a lot of work on this. It looks like he must have 3D printed that volume knob or something.
Yeah, he had to print a lot of parts, including a battery cover, case cover. That was missing.
Oh, really? Yeah?
Yeah, and some other stuff, too.
That is such a ridiculous form factor. Why did they do that? Yeah, I need to start messing around with RFID tags. I've never built anything with them, but it's like so easy, right? They just have codes on them and they speak serial to your microcontroller and they say, here's some numbers. And then you say, oh, those are the numbers. And then you have it do whatever it is you want to do. But that interaction is, it's almost magic, right? You just put the thing on the other thing and it reads it as if it were. There's a bunch of kids' toys here that use RFID things to, we have a Tony box, it's called, that my son had when he was littler. And it's got a bunch of little figurines and you just put them on the top of it. And it plays the album that you have preloaded on it that corresponds to the different figurines. And that was just such a cool interaction for little kids. Because, they can understand what happens when I put the little character on the square block and it plays his audiobook or whatever, right?
Yeah, I saw something like that not too long ago, and it was, boy, was it expensive.
Yeah,
the base unit was like $100, and each story was like 25.
Yeah, these are hella expensive. I think you can get the stories for like $7 or something like that around here, but yeah, they're super expensive.
Oh well.
I think somebody's actually hacked the Tony boxes now that I think about it, because again, it's just RFID tags, right? If you can program whatever information into an RFID tag, then you win. What's with the ka-chunking on 8-tracks?
Oh, when you change the track, it makes a ka-chunk noise. It does in my experience. I haven't had a player for a while, but
So it's just switching from the one track to the next or something.
yeah.
Yeah, right on. I don't think I must have seen an 8-track player at some point in my life. I think my like uncle had one in his car back in the day.
Nice.
I think that's as close as I've ever come to an 8-track player though, and it's so foggily in my memory that it's almost useless.
And every time you access it, it becomes more degraded.
Do you think so?
That's what I hear.
You think I'm playing it down? Well, I'll stop thinking. I'll try to stop thinking about REO Speedwagon then, so that it doesn't get
Don't think about a pink elephant either.
so it doesn't get any worse. Well, just when you think you've seen every way to 3D print things, comes along Humphrey Whittingtonsworth IV. I'm so sure that's his real name, with 3D printing on a spinning rod. And this is a really cool 3D printer hack. Basically, he makes kind of a low-tech lathe out of a stepper motor and a couple bearings. He puts a rod in it, and then he nestles this up against the hot end of his 3D printer. And with custom code, can spin the rod around and 3D print along it and across it. And by doing this, he can 3D print kind of springs of arbitrary geometry, but then he can also go back and forth across the length of the rod and make really strong hollow cylinders and just all sorts of funny shapes that would be difficult to make with a 3D printer on its own, by, instead of printing across a flat bed, printing around a spinning rod. One of the things I thought was really cool about this is that makes printing threads really easy. So you can make kind of long threaded things. One of his applications is to make a custom air gun. And so he's making some kind of a weird differentially rifled barrel. So it like starts the thing spinning more and more as it moves down the barrel, which actually makes a whole bunch of physical sense. Must be difficult to machine. Anyway, here he can 3D print them. One of the other cool things he does is he makes a little slip cylinder that goes over the rod, and then he prints on that, so it comes off nice and easily off the rod, and then he can print, just all sorts of various springs, but not just obvious coil springs that go in both directions, so kind of webby springs that look like Chinese finger traps. And he claims he can print kind of super duper fast here, because if you think about a regular 3D printer, it's limited by how fast the bed can move and how fast the printing head can move. And here, the faster and faster he spins this rod, the more plastic he can extrude and cover it up with. So it's really kind of cool too. Anyway, just a really weird take on 3D printing that I'd never seen before. And if you have a 3D printer and are into kind of funny 3D printing, you should give this video a look.
Do it. This is super cool.
Did you think it was cool?
Oh, yeah.
Don't think I have any need for 3D printed springs, but now I want to have a need for it, right?
I think it's so cool that people keep coming up with new, like, dimensions for 3D printers.
Right.
Like the continuous bed, and then this. It's like a little tiny continuous bed. For my next hack, I have a Halloween Hackfest entry. Haunted keyboard is free from ghosting.
Boo.
Now, this is MX Jack Nelson's very first keyboard, and they decided to make a spooky one, which is very cool. So basically, you type anything at all into this bad boy, and you get an AI response that's spooky and a little bit cryptic, which you'll see in the demo video, very short demo video. There isn't a whole lot to it. There's a Raspberry Pi Pico W that handles the keyboard matrix, does the connection to Wi-Fi, sends the input over to ChatGPT, and then sends the response to your screen just wherever your cursor happens to be, like when you open GIMP, and it uses whatever screen has focus.
Oh, that could be good and bad.
Yeah.
Is this going to be a Halloween prop? Is he going to set this crazy keyboard up on his front yard with a monitor out there and have people talk to ghosts on the keyboard? Because that is a low visibility keyboard.
Ooh, there's
to
a
be
new
typing
update.
on. Like, I couldn't even.
Ooh, there's 2 new updates.
Oh, yeah?
We built the case for it.
Uh-huh.
I don't see anything about what the plans are regarding Halloween, though.
Yeah, we've seen a couple of these like mashups of putting the AI bot into things you would normally think of as being hardware peripherals, like keyboards especially, actually. There was another one that did kind of AI augmented typing. It wasn't meant to like spook you out, and so I guess it was meant to help you type things or something.
Did you see that one I in-linked to? That is freaky.
Which is that?
It's a baby doll.
Oh, that's terrifying.
Yeah. Yes.
I guess you could put a USB typer in anything.
Sidebar, we only took entries until October 11th in 2021. Interesting. For Halloween Hackfest?
Yeah, we extended it.
Okay.
Don't fret. We aren't monsters. We extended it, I think, until Halloween.
Though it would be seasonally appropriate.
I don't know whose idea that was to end it on the 11th. I actually think it's unfair to end it on the 31st because like everybody's going to be like working until the last minute on their Halloween stuff. Like I usually start Halloween stuff on the 31st. Who are we kidding, right?
I've had candy all month. I keep eating it and buying more.
Tossing crazy AIs into home appliances is going to be that's going to be a hack that keeps on giving for the next year or so.
The new hotness.
All right, next up is a video from Denki Otaku learning about capacitors by rolling your own electrolytics. He got into Nippon Chemicon, which is a company that, makes those professional electrolytic capacitors, and got to using their equipment make one himself. And actually, he made 2. He made one with kind of their normal electrolyte, and he made the other one with a brown bubbly electrolyte that I am fairly certain is Coca-Cola.
I thought you were going to say Gatorade.
Yeah, right? Well, you think that would work too, right? But yeah, it's really interesting because, I guess I have known that electrolytic capacitors are kind of aluminum and some kind of dielectric that separates them from each other and then goop in there, right? Whatever kind of electrolyte. But boy, does he go through all of everything in this video, and it's really cool. If you're doing this professionally, you don't just like pull some aluminum foil out. You actually chemically treat the aluminum so that it's got a nice clean surface and all of that. And there's a lot of this sort of thing going on here in the video. And then they electroplate a dielectric layer and attach leads. They roll it up. They throw the electrolyte in there. They put it in the can. Talks a long time about how to get the electrolyte into the separator and get it all in there. And then the part that I thought was really wild, and I guess I hadn't considered super much, was they do what do they call it? Reforming stage. So they put the capacitors for a while in a warm kind of oven, and a lot of the imperfections on the surface actually kind of heal themselves up, and the capacitor gets more and more reliable as it gets aged in this oven with voltage applied. And, it's kind of just like re-electroplating the parts of the aluminum that got hurt while you were making it. And it's really interesting. So he puts them in the oven and watches them go. And the Coke one, it's not very good ever, but it improves a lot while it's in the oven. It actually like kind of gets better and better. I guess the problem with that one was equivalent series resistance. It's just Coke just isn't a good electrolyte. But because, he kind of cut everything as accurately as he could and wrapped it up just right and all that, they basically all have the right amount of capacitance to them. So it's kind of interesting. I mean, would I ever make my own electrolytic capacitor? Never.
I conceived of trying to a long time ago.
Really?
Yeah, I was gonna use, foil and paper towels and I forget what else for the business part.
Yeah.
I didn't get very far.
I'm sure you could. I have seen people do, if you need a high voltage capacitor, something you can't easily buy, you can make your own out of mylar sheets and aluminum foil and stuff. And that actually probably makes a bunch of sense because you can't get those crazy exotic capacitors. This one's one I think you only do it if you really get the chance to go tour the factory where they're made and go play in their R&D lab. But I will say it's a really, really cool video, and it goes through. I'm no expert, but if this doesn't cover everything about electrolytic capacitors, I would be surprised.
I'd rather go to the Nishikon plant personally. I don't know if that's how you say it, but they make the most beautiful ones.
Those your favorite capacitors?
Yeah. For my next hack, I chose Commodore Dataset Does Barbershop Quartet. Man, this is cool. I can't imagine how long it took to record that barbershop song that he does. But let me back up a little bit. So Linus Atkinson took a Commodore Dataset player and modified it. And if you don't know what that is, if you didn't have a disk drive for your Commodore 64, you probably had a dataset drive, which is a tape drive that uses cassette tapes to load and save files. Linus has 4 of these, but he only modified one as far as I can tell, and then quadrupled the parts to make a Weird Al style play on a popular barbershop tune from the summer of 1903.
I remember it as if it were only yesterday.
Right. My parents wouldn't let me play it on the Victrola, so I had to sneak it on the wax cylinder when they went to town once a month. No, I stole a YouTube comment. That's not my comment.
That's pretty funny.
So it actually moves its mouth. He presses a key to make all these sounds, and it moves its mouth. It didn't do this before. You had to open the door manually, but now it's got a servo that opens the door and a rubber band that closes it. And he also had to redirect the current that drives the tape head through a speaker coil so we can hear it. And then on the software side, there's a timer interrupt that runs code that toggles the output signal, and that's where the pitch comes from.
Cool.
But no, and the really cool thing is everything that he did is reversible. So he kept all the parts and everything.
I mean, of course, there's googly eyes on it, but I love it's flapping its little tape opening door open to be the mouth. That's really absolutely insane. He's done a bunch of computer keyboard into playable keyboard hacks. I think he also plays like organ. He certainly plays normal keyboard well enough to get by on that, but in the meantime, he's done enough of these other bizarre computer keyboard hacks that I think he plays music basically as well on a regular 104 key keyboard as a lot of people do on the Ivories. I'd like to start off my ridiculous overabundance of quick hacks this week with one from Al Williams, Linux Foo customizing printf. Here he's putting customized fields in there. So there's like the % capital letter or whatever, and it makes it print out a certain way. It turns out you can write those yourself. I had no idea. Al shows you how to do it in this article. Using LEDs to determine a video camera's true frame rate by Yuri Delia. A cell phone was claiming to have 960 frames per second. How do you check if it does or not? You blink LEDs that fast and you see if it can capture it. Really simple hack for people like us, but extremely useful in this case. Next up, stage lighting hack keeps La Boheme from becoming a dumpster fire. This is David Smith has taken some of those strip LEDs and bundled them all up, thrown them in a barrel, and written some code that makes them flash to make it look like there's a fire going on inside. These kind of hacks can be super effective, actually, if you get the flickering looking right. And if you are able to, by having addressable ones, you can actually have the bright parts of the fire come from different angles. That gives it an unbelievably realistic appearance. Jaffe Riddle with a funny video, The Insatiable Hunger of Paper Shredder-based locomotion. He took a paper shredder, put it on casters, fed it a long roll of paper, and watched it pull itself across the floor. Nothing else to say about that. And finally, daily inspections keep your Spitfire in tip-top shape. This is a retro-tactacular-y sort of video by, must be the Royal Air Force, about how to maintain your Spitfire in the 1940s. And Richard Beguli's write-up of this is absolutely hilarious. He does the whole thing in mock pip pip cheerio. What is it? What is this even called? What ho, chaps? Look, we know this is a bally nuisance and all, but those desk jockeys at HQ want us to watch this film about the daily inspection of your Spitfire. Anyway, you have to see it. I can't do the accent. I was totally pleased that Jenny edited this one and made it even more colloquially British.
Well, my first quick hack is that a record player in your pocket or... And man... I've heard of the hamburger record player, but I've never seen one as small as the Mickey phone, which is a pocket phonograph that, as you'll see in the short video after the break, takes about 2 full minutes to put together before you can use it. But that's fine. And it sounds about like you'd expect. It's from the 1920s, and it's portable, but hey, it's one way to listen to a record before you buy it, as long as the person selling it lets you do that. It worked like a music box. It had a big crank on it that you wind up with a big key, and there's no electricity. And the resonator is just like this Bakelite shallow canister. Next up is a typewriter for the paperless age. This comes from Adam Blumenberg. This is essentially a Raspberry Pi, a screen, a keyboard, and a small program called Focuswriter, which I need to look into, but I like it. I especially like the decoupage, which Adam says is just to cover the questionable woodworking skills, but that's fine. And finally, Adobe Scientist cuts a dash with LCD shifting dress. So I learned a new phrase, cut a dash. I had to look that one up. Let's look it up again.
Yeah, look it up again. What is it?
To look attractive in the clothes one is wearing. So basically, LCD panels here are making for a dress that, among other things, can react to movement. And you should absolutely watch the video because it's very cool, all the things that this dress can do. And it's essentially polymer dispersed liquid crystal panels using an indium PET film that is opaque by default but becomes transparent, in quotes, I say that in quotes, when a voltage difference is applied across the material. And it's controlled with a TC 4.1, but yeah, I just thought this was very cool. It's just mesmerizing to watch.
All right, that brings us to our can't miss articles. These are long form pieces written by our fantastic HACKADAY writing staff. This week I want to pick the first long form piece by Julian Scheffers, and this is also the beginning of a new series on game graphics. This one is Game Graphics Racing the Beam. And so he's starting off in the early history of video games with the kind of, Atari, NES, Commodore 64 era and how the video game graphics worked back then. And Racing the Beam, if you don't know, is a reference to the scanning beam that goes across in a cathode ray tube. And a lot of these machines back then were constrained by just not having enough memory to fill up the whole screen. All of those pixels and all of those numbers was just too much for them back then. So they would do one line at a time and calculate those out. And so they had to think up clever ways to save on memory. And that's basically the story here. And actually, this was basically summarized by commenter Ostrakus, who says, "History of cheaper memory and its effects on computer development, a non-scholarly paper," which basically is the summary here. The 3 main tricks that they used to use back then to make video games fit into tiny bits of memory were tiles and colored tiles. And so you could think of this as being a small square, usually 8 by 8, and you'd have a pattern on it. The pattern would be in a foreground color and it would have a background color, and you just put these all across. So if you think about like the floor texture that Link walks across in like Zelda, or the grass textures or something, these are all tiles. They're a particularly economical way to like cover a lot of screen real estate with not much memory. And then when you're going through each scan line, you just go through the first line of this tile and then the second line of this tile, and you just line them all up that way. Really, once you kind of understand that things are made out of tiles, you start seeing them everywhere. But then there are things that aren't tiles that run across, and particularly the characters were usually done with sprites, which are kind of another tile but with a transparent background. And so these would just kind of be overlaid over things. And so like when Mario runs around, he's a sprite. And so he's not static like the background or, kind of rolling across like the background. He can jump up and down and has a much more rich motion because the sprites in a lot of these old machines were drawn by the GPU. And so you just say, this is sprite 17, I want you to put it at this position, XY. And that was all the code needed to do, all the CPU needed to do. Easy way to get some motion over the top of this tiley background. And then the last thing he brings up are scan line interrupts, which are really interesting. If you think about this kind of beam rastering from the top to the bottom, the computer has to know whether it's on line 1 or if it's on line 300 or if it's on line 500 at the time. And one of the tricks to do things like Mario Kart, where you have a road that kind of tapers off by perspective into the distance, is you just say when you're on line 1, you draw this road object thinner, and when you're on line 300, you draw this road object bigger. And so you just multiply its coordinates out by a little bit, and that gives you automatically this kind of perspective look to it. And if you look at those old games, they're also like they have these alternating patterns of light, dark on the road to give you the illusion of driving through it. And they had to do that also horizontally because, that's the way the scan lines worked. So there's some really interesting, sweet little tricks and hacks that made these old games work and kind of gave them their characteristic appearance because they were constrained by the hardware of the time. So the games themselves kind of reflect this constraint, which I think is really neat. And the other thing I think is neat about these is, although these are describing, fairly primitive gaming machines, they're all of them kind of on par with what we have in microcontrollers these days. A lot of these old tricks are probably kind of more useful again in terms of, things you can do on an Arduino or a PiPico ESP32 or whatever. And I know we've seen a bunch of people implement some of these old video game techniques on modern microcontrollers. So if you find yourself needing to do microcontroller graphics, this stuff is like, it's like 1980s history, I suppose, but it's also useful tricks at least to know about in the modern age if you're ever working with anything that doesn't have a lot of memory. And if you want to dive deeper into this whole kind of racing the beam era of video graphics, Charles came into the comments and linked in what is hands down the best video I've ever seen on the topic, which is a talk given by David Crane, who was at Atari at the time and then was one of the principals at Activision when they split off from Atari. And he just goes through all of the hardcore detail about how these old graphics used to work, in particular in this talk on the Atari 2600. It's like an hour and a half long video, but it covers absolutely everything you need to know about how graphics worked back then on the Atari 2600.
Oh, that means it's my turn.
Yeah.
Well, for my can't miss, I chose my own You've Got Mail, grilled, scrambled, and other delicious stamps. And speaking of series, this is the last piece in this series. So we looked at a lot of stuff in this series: postal machines, the first automated post office, zip codes, and then I finished it off with some stamp trivia, and I certainly couldn't. There have been so many different cool stamps out there. Somebody brings up plastic stamps.
Oh, wow.
But that's just a small part of this article, because this was mostly about the attempts that the USPS made to stop postage reuse, which kind of seems like a strange thing these days because it really doesn't cost that much still to mail a letter. So back in the 1860s is when this was really a problem. People found a way to wash off the cancellation ink and reuse the postage. So the USPS came up with this way to make small impressions that would break up the fibers and let the ink soak in. which would make it a lot harder to remove it without just wrecking the stamp completely. Several decades after that, they tried phosphorescent tagging. So you could, they would apply something that was only visible under UV light. Then they tried microprinting, which is what it sounds like. They would just use little phrases like USPS or forever spelled different ways, spelled in like script kiddie ways.
Postal script kiddie.
Yes. And then more recently, they did something called scrambled indicia. And that just means distinguishing marks, though it also happens to refer to the markings that you see on bulk mail, where the postage is prepaid by a machine. So scrambled indicia is a hidden image that you can't see with the naked eye. In fact, you needed like a secret decoder ring, a special decoder, lenticular decoder, which as I speculate, I wonder if any lenticular sheet would work, but I don't have any in my collection, nor do I have a lenticular sheet, but I'll have to report back.
That example is crazy looking. I don't know how that even makes sense. I really like the look of those like super old stamp canceling grill things. Like they were really just like, it looks like they hit it with a meat tenderizer or something. Just like bonk. You're not going to use this stamp twice. Sucker. Yeah, I guess that's a real problem. I've never tried to wash the cancellation marks off of a stamp before. I mean, how desperate do you have to be for like 8 cents or whatever? Do you have any scented stamps?
Not yet, but I will.
Is that right?
Some of those. Mm-hmm.
Is that on your list?
Gotta get some scented stamps. Oh, I was a big sticker kid.
Were you?
The scratch and sniff stickers are the best.
Totally. I think over this whole series, how many articles did you end up doing in the mail series?
Let's see. I want to say 7?
Yeah, I just think it's a really cool series. I know we've covered them. We've covered a couple of them on the podcast. Fitting that you would say farewell to the series with us.
Goodbye, series.
It's amazing how much kind of tech / big engineering / country scale planning and thinking things through there is in making a mail system. And I think...
Oh, geez. Yeah.
Yeah. Dan in particular was just like, I think it was the zip code one. He was just like, this is civilization. The kind of like building these giant systems to handle these insurmountable problems that then also kind of at the end of the day break down to individual people who have to figure out if they could give you this piece of mail or not. Yeah, it's kind of a really bizarre and uniquely human. That's kind of dumb. I mean, apes aren't sending each other mail. But it's kind of a very human, it kind of is civilization, right?
Yeah.
Thought it was really cool that you did this and then dove in on all the tech.
Oh, thank you.
Thank you. That wraps it up for this week's HACKADAY podcast. Thanks very much for listening. If you'd like to comment or follow the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. And until next week,
keep on hacking. Ooh, it's time for the capacitors one.
Just when you thought 3D printing was done.
Start.
Hello and welcome to HACKADAY podcast. What is this?
What are we doing?
Who am I?
KaboomBox is a firecracker. Damn it, and I accidentally closed the tab. My package is here. I'm so excited. Whoa. Oh boy. Oh boy, oh boy, oh boy. Is it my turn? We gotta call it something. We gotta name this baby.